All right, let's go ahead and learn today objective 1.3, right triangle trigonometry, okay? So whenever we're using right triangle trigonometry, we always have to remember Pythagorean theorem, okay? Pythagorean theorem is a squared plus b squared equals c squared. But since we're dealing with trigonometry and we're dealing with unit circles, we can switch this to x squared plus y squared equals the radius squared. So whenever we're dealing with right triangle trigonometry and unit circles and circles, we have to also think of Pythagorean theorem in both ways. All right? Okay. Before we start, we need to be familiar with a few things. Okay. If you want to be successful in this unit, you need to know these two things all from the top of your head. Okay. All the time. Be familiar with all 6 trig functions. And I don't like to use the word familiar, but that's, you know, some of the instructions the book gives. It's be so knowledgeable in understanding this 6 trig functions to the point that you have them memorized. Okay, so the sine of any angle is y over r. That's what I mean. Be familiar. It's like really know this. Okay. The cosine of any angle is x over r. And the tangent of any angle is y over x. And we derive these from having a triangle inscribed in a circle. And that's why we have the radius. And that's why I just talked about a second ago about x squared plus y squared equals r squared. Okay? So 6, not only 3, we need to be familiar with all 6. I know that the inverse of sine is the cosecant, which means r over y. I know that the inverse of cosine is the secant, which is r over x. And I know that the inverse of tangent is the cotangent, which is x over y. You need to be so familiar with this that needs to be fresh in your mind, forefront of your mind all the time, okay? Another thing I need you to be very familiar with it is knowing where the trig functions are positive and negative, okay? So if I have my quadrants here, quadrant 1, quadrant 2, quadrant 3, and quadrant 4, I need to know where these functions are positive and negative. Remember the saying, all students take calculus, okay? All students take calculus. If you remember that, you will know that all the functions are positive in quadrant 1. And when I say all, I'm talking about sine, cosine, tangent, and their reciprocals, okay? Because if the sine is positive, the cosecant will be positive. If the sine is negative, the cosecant will be negative. It only makes sense if you have a negative fraction, when you flip it over, it's still negative, okay? So all the functions are positive in quadrant 1. Students stands for sine. So the sine is positive here because the sine is the y value, and the y value is positive, okay? But if the sine is positive, the cosecant is positive as well, okay? We're only talking about the first 3 because whatever is true for the first 3 will be true for their inverses. The tangent is positive here. Why? Because you have a negative divided by a negative, okay? Only the cosine is positive here because the cosine is positive. Obviously, when I say only the cosine, I mean the cosine n is reciprocal. When I say the tangent, I mean the tangent n, the tangent's reciprocal, which is the cotangent, okay? So once you memorize all students takes calculus, you can follow with the reciprocal is true as well. I hope that makes sense. I'll go ahead and keep on explaining in numbers, okay? So be super familiar with this too right here. Maybe you need to make a little flashcard and have it in front of you when you're doing your little Edulastic homework or Delta Math homework or whatever homework I give it to you, okay? All right, here are some of the questions you will see in 1.3. All right, identify the possible quadrants in which the terminating ray of theta could lie. So all we're doing here is deciding which quadrants. So if I give you the homework and the multiple choice is A, quadrant 1, B, quadrant 2, C, quadrant 3, and D, quadrant 4. So if I'm giving you a multiple choice, you're going to have to choose which quadrants. Could be just one, could be two. And then we give you two restrictions. We give you two requirements. We give you this one right here. Sometimes we give only one, but in this case we have two restrictions. We're saying, in which quadrant could this angle possibly exist if the sign is greater than 0? Greater than 0 is telling me that it is positive, okay? The sign is positive and the cotangent is less than 0. Well, if you're less than 0, then you are negative, okay? So I have to obey both of these rules. Where is the sign positive? Well, the sign is positive in quadrant 1 and in quadrant 2 because all and students, okay? So the sign here. But the cotangent has to be negative. If the cotangent is negative, then that means that the tangent is also negative because they are related together. So where would the tangent be negative? Well, the tangent is only positive in quadrant 1, the tangent is positive here, and the tangent is positive here. In this other two, the tangent is negative because you have a positive y divided by a negative x. So for the sign to be positive and the tangent to be negative is quadrant 2. So I would choose letter B, quadrant 2. Okay? So you have to put all this piece of information together, and it's kind of like a puzzle, okay? Sometimes we give you two restrictions, sometimes we give you only one restriction. So let's go ahead and practice a couple more times. Identify all the possible quadrants. All. Sometimes it's only one answer, sometimes it's two answers. So let's go ahead and do this. Let's identify all the possible quadrants in which the terminating ray of theta could lie. All right? They only gave us one restriction here. The secant has to be less than 0. Less than 0 means it's negative. I shouldn't have to say that in advanced math. You guys are all advanced students, but I will go ahead and keep saying it, explaining it, because we had this quarantine happening since March and we forgot all the math, right? So where's the secant negative? Well, it's hard to think about secant. Go ahead and think of the original guy, the OG here. Secant is related to the cosine. Where's the cosine negative? Well, the cosine is negative in quadrant 2 and in quadrant 3. That's where the x's are negative. It's either quadrant 2 or quadrant 3. And since it's the only restriction you gave me, you didn't give me an extra restriction, I'll choose two answers. So if I had quadrant 1, quadrant 2, quadrant 3, and quadrant 4, I will choose two answers. I will definitely choose B and C, okay? Because that's two answers that satisfy this requirement here. All right, now when you give me two restrictions, probably I'm going to be stuck on only one quadrant. Who knows? Let's figure it out. Where is the tangent positive? So the tangent has to be positive, but the secant has to be negative because it's less than 0, okay? So remember, all students take calculus. So all here, students take, so tangent is here. So the tangent is positive in quadrant 3 and in quadrant 1. However, the secant has to be negative. The secant, just again, is related to the cosine. The cosine is the x value. The x value is negative in quadrant 2 and in quadrant 3. We just did that previously. So to satisfy both of the requirements, we are doing quadrant 3. Okay, so quadrant 3. I only pick one answer. So sometimes you have only one answer, sometimes you have two answers. So please pay attention to that. Okay? All right. Then we move on to other kinds of questions, the 6 trig functions. So find the exact values of the other 5 trig functions. They're giving us one of them. We have to find the other 5. So why don't we set them up nice, the way it's always organized so we don't get confused. The sine of a certain angle and the cosecant of that angle. The cosine of that angle and the secant of that angle, the tangent of that angle, and the cotangent of that angle. They gave me the cotangent. They said that the cotangent is negative 12 over 5. So that was a given. But I can figure out the other 5, okay? So immediately we can figure out the tangent, because the tangent is just the reciprocal of negative 12 over 5. The reciprocal would be negative 5 over 12. So at least you can already get one of them based on the information that was given. Now remember, the tangent is y over the x. It's important to know that, okay? So with that piece of information that I put here in blue, plus the restriction that they put right here, okay, two things. The information that they gave me between 0 and pi, and we're not including pi. So this angle is either in quadrant 1 or in quadrant 2, okay? So this angle is either here or here, okay? However, it's saying negative 5 over 12. Where does this negative belong to? Who does it belong to? Does it belong to the 5 or to the 12? Well, if I'm in quadrant 1 and 2, the y is positive, okay? The y value is positive. So that negative must belong to the 12. It cannot belong to the y, must belong to the x. It cannot belong to the y. So the truth is, the 5 has to be positive, the 12 has to be negative, which puts me right here in quadrant 2. Okay, they're not asking me about quadrant, but I need to know that, okay? So it's either here, 5 and negative 12. Now I just need to figure out the radius, and that's where Pythagorean theorem comes in handy here, okay? So I'm going to do negative 12 squared plus 5 squared is going to equal my radius squared. So I can figure out the rest of the trig functions. Negative 12 squared is 144. 5 squared is 25, and that equals the radius squared. Then, when I add 144 plus 25 is 169, equals the radius squared. If you take the square root on both sides, on the left and on the right, you get that the radius is plus or minus 13. This is super important, the plus or minus, okay? Right now, it may not make a big difference, but the next problem, it will. Eventually, it will, okay? So is it positive 13 or negative 13? Well, we're talking about the radius. The radius is always positive, okay? So it's positive 13. So the radius is positive 13. If this was the sine or the cosine, the plus or minus would make a big difference, okay? So you will see in the next problem. So now I know that the r is 13. I can solve the rest of the problem here, okay? The sine is y, 5, over the radius. Nope, yeah, it is, over the radius, 13, okay? Which means that this is 13 over 5. The cosine is the x, negative 12, over the radius, 13, which tells me that the secant is negative 13 over 12. There we go. That's how you solve this kind of problems, is knowing where things belong, what quadrant, and Pythagorean theorem is the only extra thing we need to know. Now, in this case, it really didn't matter where I was here. It makes no difference. If I ignore this part right here completely, if I didn't do this part right here and I only did the Pythagorean theorem, I could have solved all this. But if we're talking about sine, cosine, we would have to know what quadrant we were, okay? So let's go ahead and do more problems so we can get really familiar why we always need to know what quadrant we are, okay? All right. Find the exact values of the other 5 trig functions given one of them, okay? And there's a restriction. All right, I like to set up my functions first. The sine, the cosecant, which is given to us, negative 5 over 4. I'm going to go ahead and set up my cosine and my secant and the tangent and the cotangent. All right, I like to line them up all nice and neat. Immediately we can figure out what the sine is. Let's just flip this fraction, is negative 4 over 5. Now let's go ahead and take a look at the restriction. Okay? Our angle is either in between half a pi, here we go, half a pi is right here, or 3/2 a pi. So that tells me I'm either in quadrant 2 or in quadrant 3. Okay, so this angle is either here, it's only here somewhere, or it goes all the way to quadrant 3. We don't know where this angle is. Could be stopped here, or it could stop somewhere here. We don't know. So let's go ahead and draw a triangle. I'm going to put a triangle here, and I'm also going to put a triangle down here. Okay, kind of messed up, but it's okay. All right, so let's go ahead and try to put the pieces of information we have. The sine is the y over the r. The radius is always positive. So the radius could be here, 5, or here, 5. However, the y is negative. So the negative cannot be over here on the top of quadrant 2. It has to be down here in quadrant 3. So -4. Okay? It's good to know that we're in quadrant 3. Now we can go ahead and solve for x. Well, when you see a 4 and a 5, if you solve it, you're always going to get a 3 when you do Pythagorean theorem, because it's a 3, 4, 5 triangle. Okay, so triangle. That's a classic one, 3, 4, 5. So that tells me that the x has to be -3. You can do Pythagorean theorem if you want, but just make sure that you know that it's -3. If I did Pythagorean theorem, I would do x squared plus -4 squared equals 5 squared, right? 5 squared is 25. Then notice this, I get x squared. When I subtract the 16, because that's 16, we get a 9. Then we take the square root on both sides, and that's where we get the plus or minus 3. And then you have to decide, is it plus or minus? That's why knowing where the quadrant is helps us decide. So this has to be a -3, but the quadrant also helps us figure it out, okay? So the x is a -3. Now I can answer all of the other questions. The cosine is -3 over r, because it's x over r, -3 over 5, which tells me this is -5 over 3. The tangent is the y over the x, so that would be a 4 over 3, because a negative divided by a negative is positive, okay? And then this is going to be 3 over 4 for the cotangent. So it's a lot of details, and the details is all about what quadrant and what angle, what quadrant, Pythagorean theorem, and that's pretty much it. That's why in the beginning I told you, be familiar with the x's and the y's and radius and so forth, and be familiar with the quadrants. Okay, let's go ahead and practice more, because the more we practice, the more you're going to see that I'm doing the homework for you. Okay. Find the exact values of the other 5 trig functions. They gave us that the sine is -2 over 3, but the tangent is positive. So they give us a restriction right here. Let's be careful with what. Don't assume things too quickly, okay? So if the sine is -2 over 3, we immediately can get the cosecant, which is -3 over 2. We're going to have to figure out the cosine and the secant. We're going to have to figure out the tangent, and we're going to have to figure out the cotangent. All right, so let's figure out where we are at, because it may make a big difference knowing where we are at. The tangent has to be positive. So I'm either in quadrant 1 right here, or I am in quadrant 3 right here. It's good to know. The sine is -2 over 3. This is a y over the r. So that tells me that the y is negative. You see, I cannot be here in quadrant 1. So my -2 has to be down here. -2 for the y value, the vertical, and 3 for the r. So that tells me something very interesting. That tells me that the x is going to have to be negative something. Okay? So I'm going to use Pythagorean theorem. I don't know what x is. I'm going to do x squared plus my -2 squared equals 3 squared, which is my radius. So x squared plus 4 equals 9. Subtract the 4, we get x squared equals 5. Take the square root of both sides, left and right, and we get that x equals plus or minus the square root of 5. Okay? So is it plus or minus? Because we took the time to draw our quadrants here, we know it has to be -5. Okay? And that's why some of you feel like, oh, the previous example, we didn't even need to draw the quadrants and the information, but see how it helped us here to figure out it has to be negative. So it's -5, square root of 5. Leave it alone. Just like in a unit circle, there's root 3 over 2, then leave it alone. Leave the square root of 5 alone. Do not turn things into decimals. Okay? All right, so now I can answer all my questions. What is the cosine? Well, very simple. Is -√5 over the radius of 3, which tells me that over here on the secant, I'm going to have to rationalize the denominator, okay? So on the secant, I'm going to do it separate right here. The secant would have to be, when I flip my cosine, it's going to be -3 over √5. By now, you should be very good at this. I'm going to multiply top and bottom by √5. My final answer is going to be -3 √5 over 5 for my secant. All right, what's the tangent? The tangent is the y over the x. So the y, -2, over the x, -√5. Well, let's clean that up, okay, because it's not pretty. So first, negative divided by negative is positive. That makes sense because the tangent is positive in quadrant 3. And let's rationalize the denominator. So we get 2√5 over 5. Okay, I already can do it in my head. I hope some of you can do it in your head too. So it's positive 2√5. But don't stress out about doing the cotangent. You can go straight from here to the cotangent. If you flip this fraction, you get √5 over 2. Okay, you don't have to rationalize twice. So the cotangent will be √5 over 2. Because if the tangent is positive, the cotangent has to be positive as well. All right, so I hope you understood that. Eventually, it took us a while, but eventually we got to a problem where it's actually your level, advanced math level, would be this level right here, 5. Okay, problem number 5. All right, let's go ahead and switch gears here a little bit. Oh, there's one more. Okay, let's do one more. Find the exact values of the other 5 trig functions. Why don't you pause the video and try to do it by yourself? Okay? All right, so hopefully you pause the video and you try to do it by yourself. So if the sine of this angle is 4/5, I see a 4, I see a 5, I wonder if there's a 3 involved, 3, 4, 5. Okay? The sine is y over r, which tells me that the cosecant, cosecant is 5 over 4. Cosine, secant, tangent, cotangent. Cool. The more you practice writing it in this order, the more you memorize that secant goes with cosine and cosecant goes with sine. All right. The tangent has to be positive. The y is positive, the r is always positive. So I wonder where I'm at. Okay, I'm either here or here. Quadrant 3 or quadrant 1. But since the y is positive, we have to be in quadrant 1. Because in quadrant 3, the y is negative. So we're definitely not in quadrant 3. We're in quadrant 1. Nice. Everything is positive there. So 4 for the y, 5 for the radius, and obviously the 3 right here has to be positive. So everything is positive because all functions are positive. We didn't even have to do Pythagorean theorem. We just use our knowledge here of quadrants. So here we go. 3 over 5. 5 over 3. And the tangent is y over the x, 4 over 3, and this is 3 over 4. Look at how nice that was, right? So the more you are familiar with the quadrants, and you know your y over r, x over r, and y over x, the rest becomes much easier, okay? I should make this example 1. I don't know why I made the last one the easiest. All right. So now I think we move on. Yep, now we move on to something completely different. Okay, it's our last 2 examples. Find the value of theta. So we're not talking about six-trig functions. It is the value of theta. All right? Find the value of theta in degrees and in radians. So I want two answers. Without a calculator, I wonder how many of you will be honest on this one. Well, you have to be honest. You know why? Because calculator gives you decimals. That's not true. Some of you have really, really fancy calculators that gives you in radical simplified form. So, all right, so let's do it without a calculator, and let's do it without cheating, okay? So the cosecant of this angle is -2 root 3 over 3. Well, it's really hard to find an angle with only this piece of information. Not really. The cosecant is related to the sine. So all I have to do is flip this fraction, and I'll figure out what the sine is. -3 over 2 root 3. Well, that didn't help. It does help if you rationalize the denominator, multiply top and bottom by root 3. You will get -3 root 3 all over 2 times the 3. That root 3 times root 3 is just a 3. And then guess what? Those 3 reduces, and you end up getting -root 3 over 2. Some students get really good at this, and when they see this, okay, 2's and root 3's, they know that they can go directly to this right here. Okay, they can skip all this algebra and go directly to that. Hey, if you are one of those students that can go directly to that, that's awesome, okay? So there we go. The sine is -3 root 2. Where have I seen this number before? Where? Well, obviously, the unit circle. Okay, obviously the unit circle. So go in your unit circle and look and find out what angle the sine is -root 3 over 2. So when I come over here to my unit circle, -root 3 over 2 is right here, and -root 3 over 2 is right here for the sine. The sine is the y value. So it is either 240 or 300. So this theta is either 240 or 300. Those are the only two possible angles where the sine is -root 3 over 2. In radian form, that would be 4 pi over 3 and 5 pi over 3. So those are my two answers in degrees and in radians. Okay? And that is just by knowing that cosecant is related to the sine, I can flip it, rationalize it, and get my answer. But whenever you see 2 root 3 over 3, you know that was originally -3 root 2. -root 3 over 2. Yep, I said it right. Okay, let's do one more. Okay. Find two solutions of theta in degrees and in radians. So there is actually two solutions in degrees and in radians without a calculator. I wonder how many of you don't cheat so much here. Okay, without a calculator. And is in a unit circle between 0 and 360 and 0 and 2 pi. The secant is -2 root 3 over 3. By now, if you haven't caught that secret yet, the secant is related to the cosine. And if I rationalize the denominator, blah, 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 we're going to get -root 3 over 2. Okay? So, where is the cosine -root 3 over 2? I know the cosine is negative in quadrant 2 and quadrant 3. So I'm going to go look in quadrant 2 and in quadrant 3. But I'm going to look for the cosine, which is the x value. So the cosine is -3 root 2 right here, 150 degrees. Or right here, 210. That's where the cosine is -root 3 over 2. Okay? In radians, that would be 5 pi over 6 and 7 pi over 6. There we go. Just by looking at my unit circle, we got our answers. Okay? So every time you see a 2 root 3 over 3, if you rationalize it, you can go straight to this, okay? And that's it. 8 examples. Good luck, guys. That's what your homework is going to look like, okay? Good luck. You guys are the best.